Okay, I'm going to use this video to go over graphing piecewise functions only. Okay, so the deal with piecewise functions, as we discussed in class, the function is defined in pieces. You have three functions here, right? F of x is equal to y. Y is equal to 1. Y is equal to 0. And y is equal to 2x plus 3. Those are the three pieces. Now, those pieces are defined on specific domains. That's where this comes into play. So y is equal to 1 when x is greater than 0. Y is equal to 0 between -1 and 0. And y is equal to 2x plus 3 when x is less than or equal to -1. So when I graph piecewise functions, I always start at the domain. So if x is equal to 0, what is my corresponding y value on this piece? My corresponding y value would be 1, because y is always equal to 1. On the graph, it's going to be an open circle, because according to the domain, x can't equal 0, so it has to be a hole there. Okay, on the next piece of the graph, when I plug -1 into my function, my y value is 0, because my y value is always 0. It's going to be a hole on the graph. And when x is equal to 0, because that's where my domain ends, my y value is also going to be 0. And that's going to be a closed circle on the graph. And it's closed because according to the domain, x can equal 0. Okay, then my third piece, I'm going to plug in x is equal to -1. And when an x is equal to -1, I get -2 plus 3. So I get a corresponding y value of 1. And that's going to be a closed circle. So these 4 points are non-negotiable. They have to be represented on the graph. Okay, so let me start on this piece. Now look at your domains. So my domains are switching at -1 and at x is equal to 0. Okay, so I'm going to dot those lines for the first few examples. All the values bigger than 0 are going to be to the right of this boundary line. All the values between -1 and 0 are going to be on this very limited window here. And then all my values for when x is less than or equal to -1 are going to be to the left of that boundary line. Okay, so let me go in order here. So at 0, 1, I'm going to have an open circle. And the graph has to be the graph of y is equal to 1. Y is equal to 1 is a horizontal line through 1. That's it. Never changes. It's all my values of x. So for all my positive x values, the graph is going to be y is equal to 1. So there's the piece, y is equal to 1. Okay, next, my next 2 points. At -1, 0, I put an open circle. And at the origin, I put a closed circle. Between those 2 points, my graph is going to be the graph of y is equal to 0. That's another horizontal line, and it's a horizontal line right on the x-axis. So there's my second piece. Now my third piece, I'm going to have a closed circle at -1, 1. And now, and this is where it at times can get a little confusing when we're working backwards on piecewise functions. The slope of my line is a +2, but I'm only allowed to graph that line, remember, on this interval where x is less than -1. Okay, so I'm not going to go up. So I'm not going to use my slope and go up 2 and right 1, because if I put a point there, it's not in the domain that I'm allowed to graph that line. So let me erase that point, and I only showed that for effect. Now, from my point, -1, 1, I'm going to go down 2 and left 1 using my slope of 2. Down 2, left 1. Down 2, left 1. And now I'm going to connect those points only on the interval that I'm allowed to graph that line. Okay, next one. What are the 3 pieces of the function? Y is equal to 3, y is equal to 0, y is equal to -3. Those are my 3 pieces. What are my domains? X is less than 0, x is equal to 0, x is greater than 0. Okay, so where are my pieces switching? My pieces are switching at the y-axis again, because the y-axis is the line x is equal to 0. All right, next I'm going to plug my domain values in. So when x is 0, y is equal to 3. It's going to be an open circle on the graph. When x is 0, y is 0. It's going to be a closed circle on the graph. And when x is 0, y is negative 3. That's going to be an open circle on the graph. Let's talk particularly about this. 0, 0 is just a single ordered pair. Notice how it's written. When x equals 0, y is equal to 0. That's just a single point. Notice your domains here. These are ranges of numbers. Okay? So the difference between number 2 and number 1, all three of my domains involved inequalities. So they all were ranges of x values. Here in the middle, that is just a singular point. I'm done graphing with that. Now we can focus on the other two parts. Okay, so all values x is less than 0. So those are the values to the left of my y-axis. I have an open circle at 0, 3. And what's the graph? The graph is the horizontal line, y is equal to 3 on the left-hand side of my y-axis. Now I move over here. 0, negative 3 gets an open circle. What function am I graphing? I'm graphing the line y is equal to negative 3. And I'm only allowed to graph that line on the right-hand side of my y-axis. Because on the right-hand side of my y-axis is where all my x values are positive. On the left-hand side of my y-axis, that's where all my x values are negative. Next one. 3 pieces. Y is equal to the square root of negative x. Y is equal to 5. Y is equal to negative 2x. Okay, my domains. X is less than 0. X is between 0 and 2. And x is bigger than or equal to 2. So here's x is equal to 0. Here's x is equal to 2. Okay, so here on the right-hand side, where x is greater than or equal to 2, that's going to be my oblique line, the line negative 2x. Between 0 and 2, that's going to be my horizontal line, y is equal to 5. And for all values of x less than 0, that's going to be the graph of the square root of negative x. All right, so I'm going to take my domain and plug them in. When I plug 0 in, I get 0. It's going to be an open circle on the graph. It'll be a hole. On my next piece, when x is equal to 0, y is 5. That'll be a closed circle. When x is equal to 2, y is also equal to 5, because this is just a horizontal line, but that'll be an open circle. And then on my last piece, when x is equal to 2, y is equal to negative 4, and that'll be a closed circle. I'm going to graph the square root one last. So let's start with the line. So I plot the point 2, negative 4, closed circle. This has a slope of negative 2. So I go down 2, right 1. 2 points determine a line. Connect those 2 points, and I'm done. Now I understand that that's different from number 1, but think of the domain. On this graph, we were starting and we were graphing to the left. That's why I used a slope of going in the opposite direction, right? I went down 2 and left 1 instead of up 2 and right 1. On this piecewise function, I want to graph to the left, or excuse me, to the right of 2. So I can just apply my slope as it's written. So down 2, right 1. All right, next, 1, 2, 3, 4. 0, 5 gets a closed circle. 2, 5 gets an open circle. We really like domains that are open, that are closed, that start and end, because we're really just, it's a game of connecting the points. It's a horizontal line through 5, so I got that. All right, 0, 0, open circle. Now, if you're confused, don't hesitate to plug in some values. I'm only allowed to plug in negative values of x. So if you make a very simple xy chart, if x is -1, the opposite of -1 is positive. So my y value would be +1. I'm going to pick perfect squares here. If x is equal to -4, the opposite of -4 is +4, and the square root of 4 is 2. My next perfect square that comes up is -9. Opposite of -9 is 9. Square root of 9 would give me 3. So here I am at -1, 1, -2, 3, -4, 2, and then -9, 3 wouldn't fit on the graph anyway. So now I'm just going to connect those. Whoop. Now it'll let me connect. So those are my 3 pieces. Okay, last example. So the next 4 that I put in here are, you did these as either intro or exit tickets in class. Okay, so there's 1, 2, 3, gotta go one more. So there's 4 different functions that you can attempt to do on your own for practice. Okay, and for each one, I would suggest the exact same method that we did. Until you get the hang of it, what are your pieces being graphed? On what domain are you graphing them? And then start by plugging in whatever that domain value is, and be sure to identify if it's going to be an open or a closed circle on the graph. Okay, so again, 3 functions: -2t, +5, square root of t. This is for t is less than 0. This should be a 4, not a 40. And then t is bigger than or equal to 4. So when we plug those values in, I'm going to get an output. That'll be an open circle. 0, when I plug 0 into my middle piece, that'll be a closed circle. But when I plug 4 in, it'll be an open circle. And then for the last function, when I plug 4 in on my last function, that'll be a closed circle.